Hi, everybody. I'm Tori, the co-founder of Tadata, and this is my cool team with a little help from Nano Banana. At Tadata, we build integrations for AI agents, and most software engineers know that building integrations has always been hard. Building AI or agentic integrations is even harder because these agents represent a new type of identity and need to be accounted for. They are very quick moving, thank you. And so unlike us mere mortals who spend time logging into different systems, they just want to have access and get their job done very quickly. And the third reason it's different is because anyone here who's worked with LLMs knows that they are super non-deterministic by nature and so don't always accomplish their goal, even in a very isolated system. And the entropy just increases when you add integrations and connections to additional systems. So this matters a lot right now because the LLMs have gotten super powerful, and in theory, they're really good at using tools. But that assumes that you're able to successfully connect them to those tools. And then you can build agents that help improve your own team's internal productivity. You can build agents that help your customers get more value from your product. Okay, so I'm going to talk about two technical challenges that we're working on solving at Tadata. The first one is authentication for these agents, and the second one is tool execution. Then I'm going to demo an agent that leverages a bunch of different systems, Sentry and GitHub and Linear, to debug an issue, and then talk about what opportunities are unlocked with all of this. So, challenge number one is auth. And the reason is that this is the instructions or the guidelines for authentication for the MCP protocol. MCP being the ability, a seamless and standardized protocol for agents to talk to different systems. And I had a hot sec earlier today where I thought about explaining this, and my co-founder saved you all by saying, skip it. So this is what it looks like when we are trying to solve auth issues late at night in our office. But I won't go into too much depth here, but auth is just hard by nature, and with MCP in particular, you need to have a system that implements OAuth 2.1 with PKCE. You need to manage tokens and how to keep them refreshed so that your agent always has access to the system. You need client ID metadata. And most interestingly is that most of the systems that you might want your agent to have access to, every SaaS company has implemented OAuth totally differently. And many agents, even if you can solve all of these problems and you're ready to start building an agent in LangChain, for example, they haven't even implemented OAuth in the client yet. So what we've done at Tadata to abstract away all these problems is basically make Tadata act as a gateway. And so that means that here you can see the agent that I'm going to demo. It has authenticated access to GitHub, Sentry, and Linear, but you just need one layer of OAuth to access all of these tools, or in some cases, one API call. Okay, the issue that I'm going to go a little bit deeper into is tool execution. And this is when you are trying to get the LLM to call some tool like look up this GitHub PR and retrieve that information. And it's actually really hard to get an agent to use a tool appropriately for several reasons. This is how we feel when we get it working. And the first category of problem is just getting the LLM to pick which tool to use for which problem. And here we need to do things like explaining in natural language to the LLM, this is what the tool does, and here is when to call it. Because in traditional engineering, the engineer who's building an integration has a bunch of time and forethought ahead of time to figure out when do we call this tool or API. But when the LLM is doing it, it's at runtime, and it needs to decide very, very quickly, and it only understands the text that it's given. We need to decide what tools are accessible to the LLM, And we also sometimes introduce things like workflows, which are basically pockets of determinism inside something that is otherwise non-deterministic. Second challenge is something that probably most developers here are familiar with in the context of your coding agent. Sometimes you might run out of context or spend a lot of expensive tokens, and the same thing happens with any agent. So we've had to introduce capabilities like response filtering, response projection, and response compression. And what each of these things do is context engineering that prevents the LLM from getting overwhelmed with too much information from, let's say, the GitHub service. So what response filtering does is it says, only return items that fit the criteria that the user asked for. Projection, say, only return these fields within the item that are relevant for the task at hand. And compression is something that we can apply everywhere, which just takes away all the tokens that don't contain relevant information, things like spaces and syntax that LLMs don't need, but we needed for traditional software engineering. Okay, I'm gonna skip over parameter casting and just talk about tool like execution speed. I don't know how many people here sit around waiting for their LLM to process a huge amount of information and give the right answer. An example of the type of optimizations that we bake into our integration system is tool batching. And if you think about LLMs traditionally, they normally call things very sequentially. And what batching does is it introduces parallelization, a concept that we've long had in engineering, so that LLMs can do it too and call many items from a system in parallel. So we created a eval internally because we want to know that the features that we're adding are making our system better. And we basically set this up to run one LLM, just Sonnet 4.5, and use tool sets created by Tadata, which I'll demonstrate, versus calling regular APIs or calling naive MCP servers. And we see results like increased goal attainment of just getting the job done by 30%, doing it in 50% less time, and with 80% fewer tokens. Okay, so that's a lot of what's going on under the hood. Let's see what that actually unlocks. So here, I'm going to create a debugging agent, as I said, and I come into Tadata, and the first thing is I need to access the different systems. So Sentry is our error monitoring system, and I've authenticated there with OAuth. Next, I want to add access to GitHub so that my agent is going to have the code context that it needs. So here, GitHub uses personal access tokens, so I'm authenticating with that. And finally, I'm going to add Linear, which is the task tracking system that we use internally. Cool. And then if I remember correctly, I wanted to rename my server. Ran this morning. Cool. And so what's really interesting here is that I now already have a system accessible via that URL at the top that has all these tool sets available, and I can immediately plug them into any coding agent that I want or any client that I want to access the system. In this case, I'm just doing it in our playground, and I say, what is the root cause of insert Sentry URL here? And the LLM goes out and it calls Sentry and it says, oh, the root cause is some issue with the JWT token management. So the next prompt I'm going to give is saying, in our GitHub repo called Tadata Platform, do we have any PRs that caused any changes with the JWT token management in the week before this Sentry issue started popping up? And off the agent goes, retrieving all the information from the GitHub sources. I just ran it straight. It actually did a lot of tool calls, but it gives you a sense of what it really looks like because it did a lot of tool calls and it got the right answer. And of course, it can be further optimized. But what's interesting is even when it has a couple failures, it is able to bounce back and figure out other ways to get the answer, and then it finds 1, maybe 2 PRs that changed JWT token management in the week before we started seeing this issue. Great, so last step is I want to create a linear issue to investigate this, and I want to include the context from Sentry and from GitHub. And the agent will go ahead and do that. And what's the most important thing to take away here is, yes, I could have individually hooked these tools up to my coding agent, but what's powerful about this is that this is actually a tool set that I can now hook into an agent, and that agent can run by itself every single time we see a Sentry issue. And it's something that can even be encapsulated for end users to access. So here you can see the linear issue that it created. Cool, so what does this unlock? So our team has been creating a ton of cookbooks of just ways that we use AI internally, and then we also share them out so other people can benefit. And it's a lot of things that enable, for example, combination of external and internal data. Oh, that is not what I see on my side, but anyway, we'll skip that slide. Okay, and then we've built this connector marketplace where we basically do all the grunt work of authenticating, figuring out the OAuth of every different service, so that people can just come in here and grab off the shelf whatever combination of tools you or your customers happen to need. Plus, if you don't see what you need here, we also have this solution where you can come in and bring any OpenAPI spec that you want, and we'll give you this thick layer that translates that traditional software logic to speak the language of the LLM and work very well for an agent. So that's a little bit about the OAuth challenges that we go through, a little bit about how we do tool optimization. If you want to try it out and have some agents of your own, you can feel free to do that. And then we are also hiring engineers. So if you want to connect with me digitally or after the other talks, I would love to do that. Okay, so the question was, how do you deal with cost with an agent like this where you might want to run it to debug all the Sentry issues, or how do you think about that? So no, we wouldn't necessarily want to run it every time. So what we're doing is enabling things like triggers that have logic like what you're saying. If it's above a certain severity, if it's been seen a certain number of times, then we want to trigger this workflow. Yeah. Actually, and I should not say the word workflow, but one part I didn't get into in this spiel is that another reason why these tool sets are so powerful is that traditionally a lot of people have been building agents like workflows very linearly, and what makes this so timely is that with deep agents you want to just expose a set of tools and let the agent choose what tool to call when. That also can be a cost-saving mechanism because you don't need to run everything when the agent has judgment and can decide what's relevant for the task.
Okay. We're going to give an introduction and motivation for browser automation, talk about web fundamentals, talk about AI meeting automation, browsers that don't trigger alarms, and Q&A. First, an introduction to browser automation. So browsers are complex, right? There's this quote, the automation of automation, the automation of intelligence, such an incredible idea. Anybody know this? It's Jensen in 2021. So it's like the web is a tool made for humans. And we're building AIs that are working with these tools for humans. So you can imagine, yeah, as I mentioned, humans use computers, right? And over time, we've built APIs so that robots can use computers. But now we want robots to use computers to use APIs and other tools to browse the web. And so adaptive browser automation with AI. So over the last year and a half, been working with web automation for automating things like Gusto and Rippling using LLMs and Playwright. So some of the problems that I've faced is there's no APIs for some of these critical workflows, like being able to browse payroll runs and use these different websites. There's no API and there's just a UI, and there's no stable integration path. Also, there's just complicated UIs, and even when there are APIs, they're mostly internal. These applications, they have client-side rendering, and they have shadow DOMs, infinity scroll, so many things that can go wrong. And so it makes deterministic scripts really hard, right? And traditional automation breaks when DOM changes, right? Like a website can change their class names dynamically every time you render, and pop-ups can show up. It just makes things really hard, and scripts silently fail, and maintenance of these scripts becomes a full-time job. And critically, there's no APIs for these critical workflows. There's APIs for the common cases, but the real juice is in the non-common cases. And so, yeah, many SaaS tools don't expose APIs for key actions. Some examples like payroll for Gusto, employee onboarding for Rippling, complex admin dashboards, and manual UI interactions are really error-prone and brittle. The layout and selectors may change in scripts. Right? There might be multiple step workflows. And yeah, there's also a lot of really legacy and small tools and legacy websites that make it really impossible for even doing something like Playwright scripting or DOM interactions. And so some complex UIs are the following. This is on Gusto, where you can see there's multiple pages and reports. There's some tables that are actually not HTML tables, all sorts of different layouts. You can't really deterministically, with a program, say, hey, this is all the data in JSON. Right, and so yeah, traditional web automation relies on hard-coded CSS selectors. And those are brittle, and they break easily when HTML changes. So for example, let's say you are automating Gusto, and you would like to have and select the password input, MFA, username, cookie banners, etc. You do something like this, where you have your list of selectors, and you do page.locator for that selector, get the first one, and then click it, and maybe time out after 5 seconds. Right? I'm sure any engineer can list 5 reasons why this is not great code. And yeah, web automation can break in many ways. So here's an example. We have a password input. The DOM, the next day, might change to a different name. Or the text might change. This is very common, where continue buttons are next step or something. And also selectors may change, right? That cookie banner that's interrupting your script, the way to close it might change. Data test IDs are not reliable on the modern web, even though it'd be really nice if they were. And then, yeah, it's all maintenance nightmare, right? When selectors break, your application breaks. And so you can do something find the first matching selector for something, where you have a list of selectors, and you can iterate through them and hope that you return one. But yeah, I mean, imagine trying to like debug this script and like your web automation is running for 10 minutes, and all of a sudden on this new page it breaks. That's a very real scenario. And so the real cost is like this constant maintenance of these scripts. Websites update very often, and your code needs to change. There's downtime while you're fixing these scripts. It's really hard to debug, like which selector broke, why do you need to update it. Sometimes different accounts have conditional rendering on these websites. That's really hard. And it also doesn't scale, right? The more websites you need to automate, like the more maintenance you have. And so let's talk about some web automation fundamentals. So some of the, like if you're doing automation on the web, you probably are pretty familiar with some of these tools. Playwright, so it's a modern automation library, right, by Microsoft. It's very, very clean. Puppeteer uses CDP, Chrome DevTools protocol, for being able to automate actions on the web. And you can also build your own custom CDP extensions. So this is used for things like adding a Cloudflare solver to your script, or being able to check the downloads of your browser. And so, sort of giving a summary, Playwright is really the foundation for modern web automation. You can use Stagehand for an AI wrapper on top of it. There's also many other libraries. But it has multi-browser support, auto-weighting elements, network interception, which is really useful in some certain websites that don't have APIs. You can do mobile emulation. And it's pretty reliable and developer-friendly. There's an example on the right. And Puppeteer, so this is more of a low-level library that allows for directly interacting with the browser with CDP URLs. And so yeah, it can be used for controlling Chromium. Direct access, you can have headful or headless browsers, do things like PDF generation, screenshot capturing, etc. It's pretty industry standard. And then there's custom CDP extensions. So this is an example from Undetect, which is a browser option if you're doing browser automation, where let's say you have a Captcha turnstile, and you'd like to click it. Well, with a CDP session, you can call some code like this, undetect click checkbox. And so you can also like get download URLs or other browser capabilities. So this is the intelligence layer. It has vision models, HTML screenshot understanding, automatic screen detection, dynamic playwright selection, orchestration, etc. So it allows for adaptive UI, understanding context, robust error handling, self-healing, etc. So, but that's all good. Let's show some code. So I'm not going to talk through all of this, but here's an example system prompt where you may have different, you're trying to log into a website, right? And you want to identify what is the screen type. And so you could have just a freeform text like this where you have different states, login form or choice screen, magic login link, or a logged in screen, loading screen. And you want to generate the selectors saying, hey, what are the unique IDs for these pages? What are some of the inputs? Where's like the sign in button, etc. That's what you would like to have. And so with LangChain, you can go create a prompt similar to this, where you have a base64 image of your website, and you provide also the HTML content, and you have that system prompt that we just had on the last slide. And you can say, hey, given this system prompt, let's use Claude Sonnet, and with our model call, with that message saying, hey, let's get all the valid locators, given the DOM and given the screenshot. And we can also validate that, like, hey, what the LLM said is actually correct. Cool. And yeah, you can do something like this where you say, hey, if it's a form, then you fill out the form input values, if it's a choice, if it's a link, etc. And so, I mean, overall, like this is a sort of high-level picture of how the stack works with web automation. So, I mean, robust web automation adapts to many obstacles, like handling diverse page states, forms, loading states, etc. Built-in inputs, it's reusable, and it's often built in Node.js. Okay, so next, let's talk about stealth and anti-detection of browsers. So the problem is websites are really good at detecting bots. And there's also a whole class of libraries that are really good at anti-bot measures. And it's a constant battle of sort of back and forth. And so some of the key identifiers of detecting if a website browser is a bot or not is like the screen resolution, the plugins installed, is ad block set, time zone, etc. And so there's all sorts of different detections, WebDriver, browser fingerprinting, analysis of mouse patterns, etc. Proxying is a huge thing. And this often causes your automations to be blocked, right? Or you can't like log in, right? Particularly with the login workflows, that's where you'll get sort of blocked by these AI browsers. Once you're in, then I haven't really seen anti-bot detection software being run. But the solution really is for providing some stealth browsers. So this like provides sort of a separate server that can run your web browser. It does fingerprinting, can have your time zone set. You can configure residential proxies, proxy routing, session affinity, so the same session, same requests go through the same session, same cookies, same local storage, etc. And you can also config with something like Undetect config. And so when you're doing browser automation, in general, you have a few ways of doing browser automation. You could use the client's browser. I mean, if you have like a Chrome extension or something, like that's great, but it also relies on a user actually having their browser open, right? Zero infrastructure is set up. And then like another option would be to use like a fully managed browser. Browser base is a good option. But it's sort of like a hosted browser API that you can use. But if you want like some stealth and anti-bot features, then I'd go with Undetect. It's good for high friction workflows, login walls, etc. Are worth considering with the browser is like fingerprint evasion, hosting, network speeds, really important, especially if you're loading some of these websites. Like you'll get these 5-second timeouts on your scripts if the network is just really slow. And also proxy support. So that's sort of an overview of web automation. Talked about the LLM layer, automation, using CDP extensions, stealth, and networking. Skip that. And that is it. My name is Grant. You can connect with me, Grant Timmerman. Check out my code at Grant. And ask me any questions. Thank you. Yeah. So how does Undetect actually solve these captchas? So they, I mean, I guess just to give some context, Undetect is a browser provider and library that allows you to connect to these remote browsers with this CDP URL. They basically give you this URL. And then they have some plugins that allow you to solve CAPTCHAs, right? And you can just call this one-line function in your code to solve a CAPTCHA. And it sometimes works, it sometimes doesn't. I've worked at a company where we pay a lot of money to them, and they have a really great support, and they basically do a lot of tooling for this back and forth battle between solving CAPTCHAs. The way that they actually solve CAPTCHAs, I mean, there are services that have humans that actually do that. Undetect's way is much faster. I mean, this is usually during a web automation that requires, I mean, your web session will last probably 5-10 minutes, depending on the website. Some websites like banking will log you out really quickly. But I think they must have some automation software that like checks a lot of these different cookies and other things.
All right, thank you.
Thank you.
Okay. Good evening, everybody. Thanks for coming. Thanks to Fonzie AI for hosting us. This has been fantastic. Both talks from the previous speakers were great. So, my name is Abhijit Bharadwaj. I am an engineer at Nexla, and today I'd love to quickly talk about exactly that, which is how we built agents for data engineering and how we got them to work really, really well. So, let's jump into it. Today, I want to talk about mainly three things. First, I want to start with a little bit of a background about what do we build, why do we do it, and then the next three things I want to talk about is how we can drive delightful agent user experience, it doesn't have to suck, and how we can build dynamic context systems, and finally, generative recommender systems. These sound like buzzwords, I know, but we're going to go over them a little bit, and we're going to talk a little bit about exactly what we built, how we built it, and why we built it. So, a little bit of context for people who may not know. What is Nexla and what is Express? Nexla is a data integration platform that you can use to build complex end-to-end data engineering workflows that scale, that are reliable, that have governance built in, and they just work. We have proof. The companies that use us are DoorDash, Autodesk, Johnson & Johnson, Carrier, Instacart, SentinelOne, LinkedIn. Some logos that are not here, Uber, Geico also. These guys have data engineering workflows that they've built end-to-end on the Nexla platform. For example, DoorDash uses it to, every time you go on DoorDash, you order something from maybe a grocery store or something like a CVS, that works because of Nexla. And so Johnson & Johnson does a lot of clinical trials with us, and so on and so forth. A lot of these different companies have different use cases with us. Now, but today, I'm here to talk about Express. Express is an AI agent app to build Nexla flows with just a simple prompt. Now, what that means is you can build end-to-end data engineering workflows on the Nexla platform by just a single, simple starting prompt. So that unlocks a lot of really cool stuff, and so we're going to talk a little bit more about that. Here's a screenshot. This is kind of hard to see. I'm going to try and zoom in a little bit. We'll see if we can look at it. Okay, I don't think that's going to zoom in, but this is the Express UI. On the left, you're looking at a chat that I'm having here. If you can see the text, it's trying to help me build a flow with a MySQL source. And on the right, you're seeing here a canvas view of the flow that I've just built with this chat right here. So why did we build Express to begin with? First, enterprise data is still very, very scattered. MCP is a promise for API-style workflows. Enterprise data, however, is huge, huge volumes of MySQL data that your MCP server is just not going to do anything about, right? So enterprise get data from a variety of systems to power AI reliably at scale is still a difficult and time-consuming problem. Time to value from data pipelines takes weeks, if not months now, and getting that down to minutes or hours or even a day is a huge incremental value. Vibe data engineering. Now, I don't know how many of you might like, vibe coding has become kind of like a big term now. There's some fans, there's some people who are not fans of it. But the one thing you can dispute about vibe coding is that the magic of it is freeing you up from procedural and boring and grunt work. So all you do is focus on outcomes and enjoy the thing that you're doing. We're trying to bring that to data engineering, bringing the magic of vibe coding to vibe data engineering. And then finally, this is my favorite one, more people build more cool stuff. I think that's pretty important. I think if you can bring down if you can reduce the barrier to entry, if you can reduce the friction that's needed to do something difficult, you actually just enable more people to do more cool stuff. And I think that's really, really important. So agent UX does not have to suck. So this is the first one I want to talk about. It is our generative UI layers. This is the first piece. Now, what do I mean by agent UX does not have to suck? Text in and text out can actually be poor user experience quite often, because chat interfaces, they're not very good at complex, structured, and multifaceted user affordances. Let me give you an example. If you get a form that you need to fill out with 15 different fields, each of them have validation rules, each of them have particular data types, each of them have their enums, their selects, their different kinds of forms, trying to do that with chat is an absolute nightmare. ChatGPT will give you a chat in and text out interface, and that works for quite a lot of things. But when you're trying to do something structured and significant, like a data engineering workflow, chat in and text out is just a poor interface. Second, data exploration should be interactive. So let's say you have a MySQL table. Let's say you have a MySQL database with a lot of tables in it. Each of them have their own schemas. They have a lot of sample data. Trying to explore this data before you actually build a data engineering workflow using chat is an absolute nightmare. But trying to do that with a dynamic interface is something we solved many years ago, and we actually do really well. So you can click into your table, you can look at sample data, you can explore schemas, you can do all kinds of cool stuff. Maybe you're looking at your Google Drive, you're trying to find the right files that you want to actually look at, you want to build a flow with, or maybe you're testing an API endpoint. And all you want to do is get some sample data. You want to test it, you want to look at, see what data is coming out of it, and then you want to build your data engineering workflow. Doing this with chat, again, not ideal, but doing it with a rich, dynamic user interface, brilliant. Finally, seeing what you built is important. If you built a complex data engineering workflow and all you have for it is a bunch of text from ChatGPT, not ideal. You'll have to look at it on a canvas. You can maybe do some customizing with it. You can maybe look at how it's running. You can maybe look at some resources. You can maybe look at some errors if you have them. You can maybe look at some sample data. A whole bunch of cool stuff you can do if you have a powerful, beautiful canvas to look at it on. So this is what we built. We built a generative UI custom framework that runs within Express. Now, how does this work? Express can do both. It can reply to you in text. It can chat with you like any other chatbot can. But it can also intelligently build dynamic interfaces on the fly based on what you're working on. And you do this for a variety of reasons, but one of the reasons it does it most often for is to collect structured inputs with validation, and it can surface relevant data exploration views and display rich visualizations for workflows, and a lot more than that. Here on the right, we're looking at an example. Yeah, at the top, you can see Express said, perfect, let's set up a news API source. So I'm trying to set up a template, like an API source to get a bunch of news from a country or a topic that I care about. And then I'm trying to move that to maybe a MySQL or a BigQuery for whatever reason. And it said, okay, I'll help you set up this news API source to fetch US tech news and then headlines from that. But I need a few details. So Express now knows that the input that you need to give it is structured, has validation rules, it's going to be important, and needs to be a very, very specific way. So it's generated this form for me where it's asking me for a source name, a data refresh schedule, how often should this flow run, and then at the bottom, if we scroll here, we can see some more parameters that it's asking for. Express is also intelligent to actually go figure some of this out from web search tools, from maybe past flows that you've built on the Nexla platform, and then figure out all of that, whatever it can, and only ask you for the things it really needs. So that's one example of generative UI. Another one here we're looking at. So I said I want to move data from Shopify. Cool. Shopify has a lot of endpoints. It has, you can get your orders, you can get customers, and products, events, a bunch of different things. Express said, okay, pick which one you'd like to use. Now this is a kind of a simple use case, right? You could do this with chat, but this is a place where you drive delight in agent user experience, which I don't think we're seeing enough of. And here, it's a very simple click and point, and I just need to say what I'm using, but I just get a bunch of convenient options that I can just click, and then the agent knows what I want to do. And then we keep moving. What would take me a few seconds to type out now takes me less than a second to just click and keep moving. And on the right, we're looking at this test endpoint experience, this data credential viewer experience that we've built, that it is rendering for me for the Shopify API credential that I have on the Nexla platform, where it's saying, okay, this is your get all customers endpoint. This is the configuration parameters you need to give me. I'll pre-fill it with this 2025 API version. And then boom, we have some test endpoint samples here that we're looking at for some customers from our Shopify store. So this is another one of the ways in which generative UI surfaces itself and empowers really powerful, rich, dynamic user experiences within the agent chat. The thing you might see here at the bottom is how this actually works. So what Express is capable of doing is it's capable of building these elements in XML, very clearly just building the most simple elements in XML with functionality built in, and then that turns into rich React UI elements. So this is a two-sided thing. Express is constrained with an XSD schema, so it has a very defined, constrained set of schema on kind of what XML elements it can actually build and generate. And then based on that, Express, with a very high amount of reliability, is able to build these XML elements, which then turn into React UI elements on the front end. So this is a two-layer system that works together to actually build this. Now, some of you might say, well, why not go the direction of Vercel and some of the others who are, not so much Vercel now, but I think there are a lot of people who are generating React code directly from the agent. Personally, I think there are a few weaknesses with that. First being that you can't really customize what comes out every single time. It's very hard to constrain it to be the exact same every single time. You might have some functionality that you want built into the components that the agent is just not going to be able to generate runtime. Even if you wanted to be able to do that, if you may do that sometimes, the amount of context you give it to actually work and do that reliably every single time, a lot of times, is very large. This actually gets around that by constraining that problem in just a simple schema, and the React UI does what it does best, which is render rich interactive UI elements. So that's one component. That is the generative UI component. Moving on. Dynamic context systems. So I think something we talk a lot about at Nexla on the AI team is knowing, learning, and forgetting. The agents that power Express are actually able to do all of that. So how does that work? Agentic exploration. What that means is Express can actually explore things that you've already done on Nexla. Maybe you've built a complex data engineering workflow that pulled in data from Shopify, that added a bunch of transformations to normalize currency data, to convert addresses, to put zip codes in there, to do all kinds of fun, fancy stuff. And then you moved it to BigQuery and did a bunch of analysis on top of that. Express knows that. Express knows you did that yesterday. So Express is not going to ask you the same questions to build that a similar flow again. Express is going to explore similar things that you've built before and then work on top of that. Second, progressive context loading. I think this one's pretty cool. This one's exciting. The reason this one is cool is because Express, when it starts, actually knows only a very few basic instructions. But depending on the type of task you actually want it to do, let's say you want to build an API source. Let's say you want to get in data from Shopify, in this example. Let's say you want to get in data from your Supabase. Let's say you want to get in data from your Google Drive, your S3, or whatever it is. Nexla has, by the way, 400 plus connectors and even a connector to build any connector. So really, you can move data from anywhere to anywhere. They're bidirectional. And so if that's the case, every instruction to do every one of these tasks is not the same. It can learn these tasks during runtime using tools and using various other kinds of capabilities to actually figure out how to do things also and not just what to do. And that is progressive context loading. Intelligent context compaction is the next piece. So if the second piece actually is able to learn new things on the fly, you may ask the question, well, if you've already completed a task, do you still need to know how to do it? You don't, because you've already completed it. Maybe those instructions don't have any bearing for future tasks, so let's just forget it, right? So agents are now empowered to actually forget that stuff, to learn and to forget and to know what really matters, and only that much. So intelligent context compaction in the Express system can identify previous context that is no longer relevant, and then it can just compact it or discard it. But I think the key piece is relearning after forgetting. Agents are now also empowered to actually go and rediscover this context and figure out, okay, I think we needed this piece again, we forgot it, let's just go rediscover it. Let's learn it again, and let's keep building. Let's keep learning. And the final piece is multi-agent workflows. Now, I think personally, as my personal opinion, I think multi-agents are a very complex thing that I think a lot of people are trying, and still I think that's a space that's still maturing. But the way Express does multi-agent workflows is with a set of agents that have defined roles, where one is the kind of planner or lead agent that actually figures out how to do the thing you want to do. And then it has access to specialized small agents that can do very small, constraint-specific scoped tasks really, really well. So I think that, in our experience, in our learnings, I think that's been the model that's worked really, really well for us. We're exploring a few different things there in that direction also, and I'm happy to talk a little bit more about that. Actually, I'll give one example. Maybe one example that you might have seen with Cloud Code is the main agent being able to launch off an Explorer planning system. So maybe we have Express, we give Express a task that Express believes is too complicated to finish in one go. Express says, all right, let me go launch off this exploring planning thing. The exploring planning thing goes off and writes this big doc and says, all right, I did this read-only agent task that I have a bunch of tools to do this. I did all this stuff, and this is what I discovered. Go and do it. So I think Cloud Code and some of these others have a similar model for for building multi-agents. And I think that's one of the things that we're exploring with Express as well. Now, I put in a little meme here. This is not really like a meme, but it's just something I saw on Twitter that I thought was kind of interesting. This picture was posted by what I assume is a student, a CS student at a college, and he posted this picture and he said, "All my CS classes are just this." And I think it's kind of true. Thing 1 and thing 2 don't really work together really well. That's a problem. How do we solve it? Thing in the middle, boom. So I think a lot of systems that we build are kind of like this, and I don't think building agents is actually much different from this. Building agents is still very much about classic software engineering and really, really good principles there. And I think with classic building really good agents, that thing in the middle ends up being your tool use. And the personal learning that I've had, and then I think we've had on the Express team also, is that good tool use really is about writing APIs, except they're in English. And they're not in Python, they're not in JavaScript, they're not in whatever. They're writing good APIs, but they're writing them in English. And this English could be, maybe it's the tool names themselves, maybe it's the parameters you put in the tools, maybe it's the doc strings you write for them, maybe it's the prompting you do in the system prompt, maybe it's prompting you do elsewhere, maybe it's something that's loaded into context. You write really good APIs in English, and you watch your tool use get really, really good. I think that's kind of the key learning we had around tool use. Now, the final piece I want to talk a little bit more about. I think I'm rushing a little bit fast here for time, but generative recommender systems is something I'm really excited about. I think with LLMs and how capable they are and what they can do in really, really constrained settings, we're seeing a new kind of recommender systems really come to life and do really, really well. My favorite example of this, of course, is Cursor Autocomplete. Cursor Autocomplete Cursor Tab actually gives you a really rich set of suggestions and recommendations inside of your work that actually speeds you up significantly. And that is a classic example of a generative recommender system. So we thought about it. We thought, how can we bring the magic of generative recommender systems to Express? And what that often means, at the starting point, this is maybe the first screen you come to when you go to express.dev, is you see ideas curated for you. So this is my ideas curated for me based on things that I've been doing the last week. The first idea is move some state data from Google Cloud Storage to BigQuery or Snowflake, or monitor data quality in Snowflake for engineering metrics, Postgres S3 or Postgres performance monitoring, and a few other options. These 6 options that you land on inside of express.dev are always customized for you. When you land on Express, Express knows what you've built before, knows what you've done, knows what you like to do, and knows what systems you have access to, and it's going to suggest those for you. So that's maybe piece 1, where we can actually generate some recommendations that actually make you faster at the thing you like to do. Now, here's 3 other examples of what it means to predict the next best action on the Nexla platform. So maybe the first one is auto-completing pipelines. Let's say, this is maybe an example of a response that Express might give you and say, from MySQL sources, I notice your org typically schedules daily runs. And I know this because I saw 4 similar flows that ran one time. Would you like to go ahead and do that? That's an auto-completion for a pipeline that now you'd have to spend a significant amount of work actually just setting up and making sure it runs correctly, that Express and Nexla can work together and just take care of for you. Second is schema-aware field mappings. What that means is maybe Express is able to look at your past flows, and it will say, okay, every time you've moved in data from your Amazon orders for your store, what you've always done, and what seems like your org always does, is it keeps these order IDs, these SKUs, the shipment date fields, and doesn't really care about the gift price and the gift wrap message. Do you want me to just go ahead and apply these defaults? As a data engineer, this is something that maybe is easy if you have organizational and kind of tribal knowledge. Otherwise, you actually go and look at past systems, you go and look at what others have done, you can talk to other people, you spend a minimum of hours, if not longer, actually trying to rig these systems up together. This is a simple example, but these examples, if you've done data engineering or similar kind of work, you know that these kinds of things scale and become tremendously hard over time and over complexity of systems. And then finally is transformation logic. I think transforms is kind of a can of worms with data engineering, because there's a lot of ways you can do them and there's a lot of things you can do with them. But in this case, let's say, for example, for a Shopify order source, I can concatenate order ID and SKU to create a new ID field and handle currency conversions. I'm going to build a Python transform to you. Are you ready to run it? That's how simple it is to work with Express, because Express knows what you'd like to do, what you've done before, what works well for your company, for your needs, and then actually just suggest it. So I think we're seeing this new class of generative recommender systems that are popping up in various systems. I think Express, we're really excited about it, because Express can really empower you and speed you up in your data engineering workflows with really smart recommendations. that is the final piece. So those are the three things I wanted to talk about. I rushed them really quickly. I can do a very quick small demo of a chat that I've already had with Express instead of doing a live chat, I think, just in the interest of time. But this is me. I'm Abhijit Bharadwaj. That's my LinkedIn. Those are my emails if you want to get in touch, chat about anything at all. Always happy to do that. Thank you. Really quickly, if I can do this too, if maybe we have a couple minutes. Do we have? All right. I'll keep it to a minute. This right here, what we're looking at, is a chat that I had recently where I said, I'd like to build a new flow and use News API as my source. So, get some news from this News API source. This is a template for an API connector that we have on the Nexla platform. Express knows this, can learn about this, can get the right instructions and information to actually build this on the fly. And so Express said, OK, I can help you do that. But I found you have several credentials available on the platform. Maybe some of them are mine. Some of them are credentials for my coworkers. So it gives me a quick actions choice. As you can see, I can just quickly hover over them, select one of them. In this case, I said I want to use this one. Cool. It said, all right, let me get source configuration for this. News API has 3 endpoints. What would you like to use? So I said, all right, let's get, well, actually, in this case, I was a little bit frustrated. I said, I don't want to actually do anything. Just use the tech news. Just get me US tech news. I don't care. And so Express is like, all right, no worries, I'll do that. These are the only details I need from you. I just need the source name and description if you want to call it anything, and some cron scheduled stuff. And then that's it. My source was activated. This is pulling in data and streaming all the way through these flows live on a cron schedule that I select and pulling in news information. And I said, cool, the next thing I want to do is maybe add a transform, convert author names to uppercase. Very simple use case here. And we can actually, let's see if we can go and take a look at some of these. Let's zoom in a little bit. There we go. It wrote a very simple piece of Python code here just to convert some fields like author names to uppercase. So in this case, pretty simple, but it can actually go ahead and apply these complex transforms. One of the things I would say quickly about our transform capabilities is that it can write these transforms in Python. It can build SQL transforms for aggregations. It can also build transforms in our custom DSL that's based off of Jolt. So if you're familiar, we've built a bunch of functions that can do transformations based on classic Jolt transformations. So that is another example. In this case, it was pretty simple, so I just wrote a little bit of Python code. And then finally, I said, I want to move this data to my BigQuery table. Right here. I said, OK, just use this credential, use this database, use this table, come up with some automatic mapping. I don't care. And it actually said, all right, I'll just go ahead and do all of that, connectors, transforms, getting configuration, building these field mappings. And then boom, this data is now moving to my BigQuery. And just this simple chat of just a few messages, I have data flowing in every day from my News API source, getting news from US Tech News, and moving it to BigQuery. So yeah, that was it. That was a really quick demo of the chat. Thanks for listening.
Any questions?
Yes, sir. Please, go ahead. One of the things we've seen is, with the advantage of using XML in this use case, is that we're actually able to stream the UI also. So it's not structured outputs. It's not deterministic, just like kind of wait until it finishes. It's actually streamed live, so these UIs are getting built live. That's one piece to it. But the other piece to your question is, can these components be preset somewhere else and then be fetched in real time? What we've seen, we've tried a few different variations of this, but I think the one we had the most success with is constraining the ability of the agent to generate XML elements within schema, just a simple schema XSD file, and the actual deterministic logic of how those components gets built just can live in the React codebase, and then those XML elements that are generated out of the agent can actually just match to which React elements have to render with custom attributes and props that are kind of baked into the React codebase. One of the reasons for doing this is actually we found we can build a lot more function, we can bake in a lot more functionality into these React components within the UI codebase when they're just matched with an XML element. Now, can we fetch them from somewhere? We can, but it actually adds a decent chunk of back and forth for not an incremental amount of benefit we got from just baking in the XSD schema and then baking in the elements within the React codebase. So we tried a few variations of it. That's a great question, but I think we found the most success with this like kind of back and forth schema.